Am I audible? Good? Okay. Welcome, everyone. We'll get started with DataOps and full Snowflake automation in one click. You guys can hear me in the back? You guys can hear me? Yeah? Perfect. Thank you. Okay. So we're going to look at what is a DataOps in terms of what it means to automate all things Snowflake. Okay? So we're going to focus more on DataOps in terms of what we can do with Snowflake. So first, let's talk about what problem are we solving. So every time you think about, the types of challenges that your data practitioners have, there's always going to be a lot of complexity. It takes too long to get, data products rolled out. It takes a lot of time to get a lot of the details that are necessary to create these data products. You're always dealing with multiple environments, dev, test, QA. So your teams are always challenged. If you think about how the world did software engineering for the longest time, delivering software products, why can't we do the same thing for data, right? So if you think about it, we've had things like DevOps and CI/CD platforms for the software engineering world, and these things allow us to do testing, code reviews, allow us to have governance around these processes. Why can't we have the same kind of thing, but for the data practitioners? So we at DataOps thought long and hard about how do we solve this problem, and we said, well, this has already been solved for a lot of the software engineering world. Why don't we take those same exact principles and then bring them over into the data world? Now, to be able to do that and to be able to accomplish that, you have to take a lot of the practices and a lot of the experiences that the developer community has and then bring that to the data practitioner. We're going to walk through a number of the various techniques that are going to be employed and how do we solve a lot of these challenges. So one of the first keys in being able to do data ops is automation. You have to have as much automation as possible in order to get the kind of velocity that you need, in order to get the kind of governance that you need. If you think about what you do in the DevOps space, especially with software engineering, you're spending a lot of time working on different features. Different parts of the team are working on different aspects of that software product. They come together at some point, they do their testing, they do their integrations, they roll this out into different environments. Only when all these tests get passed do they make it into production. We need the same kind of discipline in the data space as well. When we deliver a data product, we want that data product to be trusted. We want to make sure that along the way, all the features, everything that was incorporated to deliver that data product was tested, was validated, that people actually were able to see that these changes are indeed the changes that the business asked for, and then be able to release that going forward. And the goal here being that now the business will trust the data products that are being delivered to that consumer. So with this automation, we have to look at all the various aspects. So we have data ingestion. Without data, we can't do anything. Obviously, there's going to be modeling and transformational changes that happen to those data products as they evolve. We have to have some sort of continuous integration, continuous development pipeline, dealing with the various environments, be it QA, dev, test, however many environments the company has. All sorts of testing, like what kind of tests are we going to do to this data? Are we going to just check to see that the values are correct? Are we going to check to see that the schemas are correct? At the end of the day, we also need a lot of technical documentation. What is in this data product? What constitutes, this data product? Like, is a column a string? What is actually contained in that particular column that is a string? So in order for the data product to make sense, somebody has to be able to make heads or tails out of that. And of course, you've got all the aspects of security and auditing. So you need to make sure that the right people were able to deploy these things at the right places. So you have to have all those controls in place. So we take the experience from the software engineering practices with DevOps, and we bring the data world, thanks to Snowflake's capabilities, that makes this a true reality. So how do we do this, right? If we really think about delivering something like a DataOps platform, what's the way that you do that? If we think back to how a lot of the CI/CD platforms were built, and especially if you look at a lot of the cloud automation frameworks, if you want to deploy a solution into the cloud, let's say you need a bunch of servers and you're going to deploy an application. Well, if you did that manually, that would be very time-consuming, very error-prone. You're going to run into problems, right? So what you do is you basically specify, this is what I want that environment to look like. I need these servers. I need this much memory on those servers, disk space, and so on and so forth. And I declare that as a YAML file. And if I'm using Terraform, I tell Terraform, here's the configuration I want. Go ahead and build it for me. So now we're looking at, the imperative versus the declarative approach. How great would it be if I were to be able to tell this application, I want my database to look like this, right? Think of it like, you're using Google Maps. You put in an address where you need to go to, and you can get directions step by step. So it could be, the imperative way would be, you go a certain distance, you turn left, turn right, and so forth. So if we look at a declarative versus imperative approach, the imperative approach would be very, very specific. What does that mean? So depending on if we're looking at it from like a map perspective, I would need to first know where am I presently? Which direction am I facing? Am I facing north, south, east, west? What are other factors that might change that imperative set of instructions? Is there traffic that day? Is there a road blockage? Is there road construction? Depending on those factors, that imperative set of instructions will change. So if I had an initial set of instructions and I went to this destination once, and I know that's the only way to go, the next time I go there and there's a roadblock where there's traffic, I might be stuck. How great would it be if we could just say, hey, Google Maps, or hey, Siri, this is the address I want to go to, and it's like your GPS just takes you there. It calculates all the changes that need to take place in those declarative instructions to get you to the final destination. So if we take that into practice, what does that actually look like? Let's talk a little SQL. So in the good old days, you would write a lot of SQL, and you would specify exactly what your table structures and your database objects should look like. And then if you had to make some changes, you would have to also take into consideration what those changes need to be. Do you need to do alter statements? Do you need to do create statements? What if the table already exists? What if I'm adding a column now? Or if I'm removing a column, what do I do at that point? Well, why don't we just declare the end state in a YAML format, and then let the database figure out, or let the engine rather figure out what the database needs to look like. So it will reason for us exactly what needs to take place to get it to that specific configuration that we're specifying. So I could just easily say, I want a database that has these tables, it has these columns, and regardless if I run this pipeline once or 1,000 times, it will always be at that exact same stage every single time. So if we peel back the layers a little bit, so what's actually happening here? So you have essentially what is like a compiler that figures out all of the changes that need to be made. It does that by checking the state of the database at any point in time. So when that pipeline runs, it knows that the changes that need to be made are going to be correct. And as it does that, it generates the exact type of SQL that will be sent to the database to do that automation. Now, the title of this talk is Automation with Snowflake. So there's one aspect here that we're focusing on. We're automating all things Snowflake. And the reason we can do a lot of this DevOps type of practices and call it DataOps is because Snowflake gives us the ability to use development practices that directly map to what we would do in a developer lifecycle. So for instance, if we look at the imperative way, you had to write a whole bunch of SQL, manage all those scripts by yourself. Now we say, we're mapping all of the various objects that we can control in Snowflake, but we're going to do it in a declarative fashion. With all of those mappings, now we have the ability to control all things that are part of that Snowflake database. So if you think about the types of automation frameworks that are out there, Terraform comes to mind where, like I said, just like you would be able to deploy a bunch of infrastructure, you can do the same thing with Terraform where it says, spin all the stuff up for me, and it manages state for you at all times. So I'm a developer. How do I actually use this in practice? When a business comes to you, they'll say, we need to add these additional things to this data product. More often than not, there's already something in place. So we are going to be taking that thing that's in place, something that's already in production, and we're going to try to improve upon that. And that might mean that I'm creating some additional tables, or I'm doing some additional transformations, whatever that is. So the way I would start is I would start from either a dev branch or the master branch. I would branch that off. Again, we're using the same kinds of practices that we've done for software engineering, right? We create a branch, and then the moment we create that branch, we also have an exact copy of that database in Snowflake using Snowflake's zero-copy clone capabilities. So this is where it really comes to shine, because imagine if your database was 1 petabyte and you had to go through this development lifecycle. There's no way the business is going to allow you to make a copy of a petabyte every time you needed to test out a feature. It's just way too expensive and just impractical. It would take very, very long to do. With Snowflake's zero-copy cloning capability, basically it's a metadata operation, and it's a copy on write operation. So you have an exact replica of that 1 petabyte database where it points still to the original data, but you have the ability now to play and do whatever you need without having any fear of doing any damage to your production data. You can experiment all you want, do all the testing that you need, and as soon as you're done, you can tear that down. So now this gives us the ability to do testing with confidence. We can iterate as quickly as we want. We can introduce new features, try out new ideas, and we can do this over and over and over again without knowing that we don't have to pay a huge penalty to do this iteration every single time. Now think about that for a second. What is the type of agility that you get from having a platform like this, right? If you can remember back to the old days when we used to do things where we would copy sample data just so we would be able to test out a portion of the data product that we're building, that would take countless hours and it would require a lot of people. Different teams would need to get involved. Everybody would need to be sending data back and forth. It's never the full data set. You're never really testing out all the various edge cases. So this gives you the ability to iterate much, much faster so you can find the problems much more quickly. So what is the source of truth for everything? So again, taking the practices that we have learned from DevOps, well, why not make the Git repo the source of truth? Because all our source code is going to be there, right? If we're going to use a declarative approach, we're going to write all of this in YAML. And once we have that written down, we have that code that we can version. We can see who made the changes. We can see what commits they changed. And over time, we can see exactly how it evolved. As I'm making my changes, as I'm introducing new features, I can see exactly what's going on. And as I do the deployments, if something fails, I can see exactly at what point it failed. I could always go and revert back and then try something else. So this allows then us to go and make copies rather we can clone a repo, do our changes we need to do in the repo, push that creates a pipeline for us that triggers a CI/CD job. Everything gets tested, everything gets checked out, and then you have the ability to move this thing forward. So in actuality, what you have then is something that looks like a sequence of operations then that get turned into an actual CI/CD pipeline. So this is an actual visualization of what that pipeline would look like. Everything is defined, again, in YAML format. So you still have the declarative way of defining what your pipelines are and what your jobs are. And in each one of these steps, you can do different things, such as setting up all your secrets. So if you need to get all your secrets from a secret store, you will get those secrets. You will push them into the various orchestrators that are doing the work. Every organization that I've ever worked with has had a plethora of ETL tools and different tools in the organization. And by the way, they're not going to get rid of those tools anytime soon, right? So those tools are serving a purpose. They're doing a job. And in some cases, they're doing a fantastic job. So why not continue using those? The problem is we need to bring that whole ecosystem of tools under a single pane of glass so we control it all with a single CI/CD or orchestration plane. So having a platform like this, where it gives us the ability to orchestrate all of these various third-party applications, now we can bring them into the CI/CD pipeline, and then they can participate in that whole DevOps journey. So bringing data from external databases, S3, ADLS, internal database systems. You can do things like EL, ETL, ELT, lots of different capabilities, right? And the other thing that makes a platform like this super beneficial, you can test every step of the way. So you deploy a table, you can run a test on that table. You can check to make sure that after you've done your ingest, the data is correct. You can make sure that all the counts that were supposed to be in there are actually coming up correct, right? So you get all the checks every step of the way, and if at any point you don't want this pipeline to continue, you can have hard exits where it just stops the pipeline. Somebody gets an email, somebody has to go and check to see exactly what failed. So if you look at the various components that sit on top of a platform like this, you can have all sorts of tools that you're orchestrating. In the partner ecosystem, you have things like Matillion for ETL, Informatica, Talent. You can even have your own, Python or Spark programs where you can actually call those as well. So all of these tools come together to give you the full data ops experience. Now, if we look at a little bit under the covers, what is actually happening here? Everything is pretty much grounded by Git, right? So Git is our platform that is our source of truth. All of our artifacts live in Git. So we know that all of the code that we've put in to deliver this data product is actually in a central repository, which we could easily work with using the online tools. So if I, as a user, I feel more comfortable using the web browser, I can just use the ID in the web browser. Otherwise, if I want to use my own laptop, work in Visual Studio Code, I could always clone that repo locally, do whatever changes I need, do a git commit, everything goes back up to the repo, your pipeline kicks off, and you're doing your continuous integration. With this now, every single branch becomes its own database. So you have your prod database, your QA, your dev, all the feature branches. And the other benefit of having all of these is that multiple people, multiple teams could be working in parallel, delivering on these data products. So you're not limited to just one group being in control of all of this. If you think about how data mesh works, well, you've got different domains, each one kind of being the master of their own domain, and they're delivering data products, and nobody's stepping on each other's toes. So the various functions that you will be considering when you're doing something like this is you got to bring some data in. Whenever we think of data pipelines, we usually think of a DAG that goes left to right. We read data from the left-hand side, and out on the right-hand side is the consumption of that. So you have a lot of information that gets generated as part of this. So there's a lot of rich metadata that you have now access to as part of that pipeline. So if you need a lot of observability, a lot of accountability, governance. You get this from the platform because at every step of the way, all this metadata is being collected and is made available to you that you can put into a data catalog or to some other platform to extract that rich metadata. In the grand scheme of things, you have all of the orchestration that sits on top of all of these ecosystem of tools, where Snowflake is the data, let's call it, the source of gravity for all of this ecosystem. And everything that you're orchestrating from ingestion all the way to consumption, to your ML catalogs, to your BI consumers, and so on, is being orchestrated down to these platforms. So how do we do that? So there is this concept of a runner. If anybody here has worked with, GitHub Actions or GitLab, there is some sort of an execution activity that happens that goes and sees, hey, there is some event and I need to do something based on this event. So let's say I need to go and ingest some data. So you'll have a pipeline, an orchestrator will wake up and say, oh, I got to go in and read some data. So what it does then, it fires off the ETL orchestrator, and that could be any one of the tools that you have. It could be Matillion, Trend, Stitch, Fivetran, the list goes on, right? As soon as that ETL job is done, it moves on to the next job. So just imagine this as a single orchestrator that focuses on one particular task, and you can have as many of these as you need. So you can chain these as necessary. You can have, one be an ETL job, the next be a transformation job, and the next one be a data quality job, and so on. So what is the kind of velocity that we get from this? To put it into perspective, let's see, a particular customer's problem that they had and how they were able to solve it. So Roche Pharmaceuticals is a global pharmaceutical manufacturer. And one of the biggest challenges that they had is it was taking them a very, very long time to deliver a data product. So usually it would take them over 3 months just to deliver one data product, right? Because they didn't have all that automation, they didn't have all that governance, all of that control. By employing DataOps, what they're now able to do is deliver 120 data products per month. So that is a huge improvement in productivity. So that makes the business more agile. It makes the developers more productive, because now instead of worrying about all of the gluing the pieces together, they worry about getting their deliverables out much faster. Let me give you a quick view of what the platform looks like. So I'm just going to do screenshots because we don't have the ability to do a live demo at the moment. So essentially, when you look at the platform, it's going to look very, very familiar to anybody that's ever done any software engineering. GitLab, GitHub, Bitbucket. If you've ever used any one of those, this will feel right at home to you. So basically, you will see there's a CI/CD portion there in the pipelines, which gives you all the pipelines that were run. And for each branch that you ran, you will see the pipeline activity and the various steps in the pipeline. So for instance, this pipeline has a whole bunch of steps here, and I can have any number of these pipelines that are running, delivering different data products for different teams. The pipeline itself, once you click into it, is the step of the various activities, all the particular jobs that are being executed. And then if we look at the actual engine that generates all that metadata, generates all the objects, defines all the tests, it's all declared in this fashion. It's basically some YAML that you go and then you specify exactly what you want. So you can do all your grants, your schema definitions. You want to declare what your warehouse sizes are, what type of a warehouse it is, all the grant management and security. You can handle it all through this setup. So this makes it also more approachable to a lot more people. So you don't have to be a SQL expert to be able to write the schemas that you need to be able to be pushing to Snowflake. And the other benefit that you get here is writing tests is just adding a line to your YAML that says test this particular column. So just a tiny little bit of syntax that says test and the type of test that it's going to perform, and then the system takes care of the rest for you. So, in conclusion, what do you get? So you get to deploy data products faster, just like you do with software products. You have a single source of truth because everything is in your Git repo, and you could always see exactly what was done, when it was done, and who it was done by. Your developers are going to be much more productive because now they're going to be focused on actually delivering data products instead of managing systems and all of the nuances that go with that. You get all the governance. So again, you get to see exactly what happened in the platform over time. You get a full CI/CD orchestration platform. So if you need to build your own orchestrators, you have the ability to do that. You can do it in Python, Java, pick your language of choice. All those integrations are there. Anything that has a REST API, you pretty much can interact with. And then finally, it's got all of the automation and all of the testing that you need. So you don't have to worry about external testing frameworks that you have to build or bolt on. It's basically part of the platform. And if you do need to use a third party, something like Soda SQL or any other tool that's out there, you can easily do that through our orchestration platform. All right, that gives us just a little bit of time for Q&A if there's any questions that I can answer for anyone. No questions. All right. Thank you very much.